What's going on, my ASVAB party people? Anderson here, your ASVAB coach, and happy to give you another 2-hour class recording where we're going to be going over part 1 of Law of Exponents. So this week what we just did was we did 2 back-to-back classes to show the entirety of the Law of Exponents. That way you can learn everything you need about the product law, the quotient law, power of powers, taking the roots, looking at negative powers, looking at fractional powers, everything that you need to crush this. So here in this 2-hour recording, we go over the first half of that for free for you. And in the second half, that's actually part of my full program that my students actually pay for a very low price to get all of my classes, over 300 recordings. On top of that, you get thousands of practice problems with video solutions so you can learn from every mistake, and then the ability to text me whenever you need help. And so there it is. If you want to go ahead and get everything that I offer in a much more organized way than just this YouTube channel, then I would highly recommend you consider subscribing to my ASVAB All-Access Program. You can go and find it right over there, duranlearning.com. You'll see the yellow button that says Recommended All-Access Program. Go ahead and click it. You'll see all the details about it and a video to explain how it all works, and an easy sign-up process at a very, very, very affordable price. But at the very least, my poor people, even if it's out of your range, no worries. I do provide these videos on YouTube for you, and all I ask is that you continue supporting this channel by liking this video, commenting whenever you see something interesting in the video, and then subscribing to the channel. That way you can stay up to date with new videos and new goodies. So again, my name's Coach Anderson. Let's get you to work. Let's get you mastering Law of Exponents and keep you moving forward from there. I'll see you soon, my party people. Let's ace the ASVAB. Let's take these notes here. So let me again tell you how today's class is going to go. About halfway through the class, I'm going to stop the class and ask you guys about what you guys would prefer to see for next month's group tutoring classes. I'm going to ask you a couple questions, but for right now, let's go ahead and really dive in. Let's take these notes here. So first of all, go ahead and write this down. First of all, we are talking about multiplying and dividing the same variables. All right, same variables. So here are the rules. Hopefully we can see everything. Everybody, can you all see this one here at the bottom? Can you all see this one right here? Cool, sounds good. So go ahead and write these 3 things down, these 3 different rules. Now, I'm gonna go ahead and show you examples coming up in a moment, so don't worry, you're gonna be just fine. But here's what you do when you are multiplying basically powers or variables that have the same base. When you're multiplying the same powers, you're just going to go ahead and add the exponents. That's it. All right. I'm going to show you the really good reason why in a moment, but I'm going to show you the rule first. Then I'm going to blow your mind and show you how easy it can be to actually understand. I got you. So when it comes to dividing powers with the same base, you'll just go ahead and subtract those exponents right there, nice and easy. And then lastly, if you have a negative exponent, what you're going to do, my party people, is basically you can switch the power between the numerator and denominator to change the exponent sign. So I'm going to give you a couple of examples in a few moments here. So right over here, I'm going to give you some examples. But first and foremost, go ahead and write these notes. I'm going to set a timer here for just about 35 more seconds, just to make sure you have all the time that you need to write this down. And anybody who's coming in late, there's only so much I can do, right? So it's all good. So given that timer there, you're going to want to make sure you have this written down because like I said before, I'm going to teach you how to recognize what rule you should be using. Then you're going to do what you need to do to memorize that rule. And then we're going to apply that rule the right way. 3 steps here. Recognize, remember, apply. Now or sometime before the end of this video, make sure to check the schedule for our group tutoring classes. Remember that we have a class, a free one, once a week. And if you register for it, it includes a free practice test with video solutions to help you learn from every single mistake. But again, check out that schedule, see when the next free class is, and register for it right now. That way you can get all those bonus features and benefits. Again, all to help you raise your score. You're watching this video, so I know you're serious. So let's take the right steps, continuously moving forward. Ace the ASVAB. Let's get it. All right, so we got about 2 more seconds, 1 more second, about a half second, about a quarter second left. Yeah, time does work that way, and we're good. So let's go ahead and get started. Let's look at some examples here. Let's understand what is going on, starting with multiplying powers. So First of all, I want you to go ahead and just write this example here. Under multiplying powers, what we have is, if we have x to the power of 3 times x to the power of 5, what we said we would do, everybody type it into the chat box. What do we do again when we are multiplying the same variable? Be specific. Add what? What? Add the money in my checking and savings account? What? Add the exponents. Yeah, add the exponents. We want to be specific here. We want to be able to talk about what we're doing every time, all right? Every time. So we have the variables. Again, they have those same letters, x and x. So we typically call that in the math world the same base. The same base. So what we would do here is we will say, hey, what we're saying is 5 and 3 added together, that gives me 8. But here's the reason why. So everybody, this is the moment. After you're done writing that down, completely put your pencil down. Put your pencil down. I want to go ahead and explain this to you. And those of you in the program know that you're going to get this recording first thing tomorrow morning. And really, it's just really important to understand why these things work. So put your pencils down, guys. Don't worry about it. I got you. I'll let you go ahead and take a picture in a second. So here's the thing, everybody. To understand this, you have to really understand what an exponent means. Everybody, if I were to go ahead and write 5 to the power of, let's say, 3, what does 5 to the power of 3 actually mean? Can anybody tell me? If anybody want to grab the mic or use the chat box, what does 5 to the power of 3 actually mean? What does 5 to the power of 3 actually mean? What's going on, Jose, man? I see you in the chat box as well. So go ahead, Jose. What do you got?
What's up, coach? You do 3 5s times. So it'd be like 5 times 5 is 25. And then 5 times the last 5, 25 times it.
Right on. So everybody, is it fair to say, so thank you, Jose. Appreciate that, man. So 5 to the power of 3, Jose basically just said, just like a lot of you are saying in the chat box, okay, if you have an exponent, that means that you're multiplying that number that many times by itself. So 5 to the power of 3 becomes 5 times 5 times 5. So instead of writing, hey, I have 5 times 5 times 5, you could just say 5 to the power of 3. Everybody, yes or no, does that make sense? Because that's a fundamental piece of knowledge that we have to have down, like no doubt about it, if you want to understand this with so much ease. Does it make sense that an exponent just tells you to multiply that number that many times? Okay, great. Now there's a reason why I took my sweet dang time saying that. It's because of this. Everybody, isn't it true that x to the power of 3 is like saying x multiplied by itself 3 times? And also, isn't it true then, playing the lawyer over here, and isn't it true then that x to the power of 5 is like saying x multiplied by itself 5 times? Isn't that true? All right, cool. So if we're following along so far, then you got this. You're good. Because think about it. If you have x to the power of 3 times x to the power of 5, what you're basically saying is you have 3 of these x's multiplied with 5 of these x's. And so instead of leaving it like that, instead of leaving it as, oh man, we have x times 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 x, we can just say this. We can go ahead and say that we have how many x's being multiplied by themselves? 8 of them. 8 x's. So we can just say x to the power of 8. And boom. So yes or no, does the reasoning make sense as to why we just add the exponents if we're multiplying powers? And that's right, Jalen, math, it's easy to love something when it makes sense, right? I think a lot of us have sold ourselves short when it comes to math simply because we expect it to make sense to us, but sometimes we have to put in the work to actually understand the mechanics, just like a language, just like learning another language. So with that said, my party people, let's go ahead and move forward here. Again, the rule is for multiplying powers, just add those exponents because basically what you're doing is you're multiplying that many times anyway. Now let's take a look at dividing powers. Now, when it comes to dividing powers, what we're doing, oh, so Rianne Norris, we're gonna go ahead and go over that in a moment. With those numbers, you just multiply them together. That's it. But I'm gonna show you an example in a bit. I definitely got you on that. So my party people, let's go ahead and take this into account now, dividing powers. So think of it like this, based off of exactly what we just said, everybody, based off of exactly what we just said, is it true that y to the power of 5, if we're looking at this example over here, is it true that if we're looking at y to the power of 5, that's like saying 5 of these y's multiplied together? Is that true? Okay, so remember, the rule just says, hey, when you're dividing the same, when you're dividing powers with the same base, subtract those exponents. That's all it says. Subtract those exponents. But let's go ahead and understand the why. Again, you're going to remember this so much longer than just what we do today. So here, check this out. Everybody, true or false? Wow, that is way too big. If we had y to the power of 3, isn't it true that y to the power of 3 is 3 y's multiplied together? Y multiplied by itself 3 times, right? Okay, great. Now I have one final question, everybody. Isn't it true, again, Lawyer Duran here, isn't it true that if you're dividing the same exact number, by itself, isn't it true that that cancels out and just becomes 1? Isn't that true? Okay. So let's check this out here. I can say that we have y and y, y and y, and then y and y. So everybody, when we cancel out, what operation did we just do? Not division. So in terms of like, I have 5 y's and 3 y's, and now I only have 2 left. What did I just do? Right. I subtracted. I physically removed the same y's that they had. I physically removed them. And so what happens is you can just call that subtraction, because here upstairs, what you had was y to the power of 5, which meant 5 of these y's multiplied together. Down here, what we're basically saying we have is y to the power of 3, which is 3 of these y's multiplied together. So if you have 3 y's on bottom and 5 of them up top, 3 of the 5 that are up top are gonna cancel out, just like we see right here. That cancels, that cancels, that cancels, and you only have 2 left. And that's why y to the power of 2 is going to be that answer. And that's why that works. Again, I don't want anybody here to join a math knowledge class, especially math knowledge. We can't always get everything down in arithmetic reasoning. But when it comes to math knowledge, my expectation is that we leave the class being able to explain something about what we're doing. All right. So with that said, on a scale of 1 to 10, how much sense does that rule make to you? If you're dividing powers that have the same variable, simply subtract the exponents, because it's going to be canceled out on the top and the bottom. Great. Sounds good. Sounds good. So let's go ahead and go through this glorious progression here and get to the hardest part of today. And here's what I'm going to say, everybody, because like this math knowledge excites the hell out of me, simply because when you get it down, you got it down. Like solving equations, systems of equations, all of this stuff, man, absolute values, inequalities. Once you got it down, you got it down. So, coach, what if the bottom is bigger? Well, think about it like this. 5 minus 3 is 2. 3 minus 5 is -2. So you'll have a -2. Plain and simple. You have a -2 for the exponent. But I'm going to teach you what to do in case you do receive a negative exponent, how to fix that and make it positive, which is exactly what we're doing right here. So let's check that out. I got y'all. So negative powers, my party people, negative powers. Okay. Well, that is negativo. So what we're looking at here is a very confusing kind of thing here. So to show you how not confusing this is actually going to be, let me just help y'all expose yourselves into how nervous this actually makes some of y'all. So everybody, negative exponents. Do you like them? Do you understand them? Or do you only have them memorized? Do you need help with them? Are you lost? What are we feeling? What are we feeling right here? Understand them, kinda, need help, lost, 50-50, hate, understand, they all right. Lost, kinda, a refresher is needed, need help, lost, need help, understand them. Okay, so appreciate y'all being honest. And for those of you that find it curious as to why I'm speaking out loud and reading the chat box, is because these classes are recorded And so I do want to make sure the interaction is felt with people who are watching the next day. So with that said, I've never seen a negative exponent in my life. I've never seen a negative exponent in my life. So here we go. This is x equals -2. She is she's ready for you to help her solve herself. And let's get to it. So, right. So with that, here we go, party people. Here's the easiest way that I can explain negative exponents. Like once I explain this, y'all are going to be having a really good time after this. And Elijah, don't worry, I got you right after this. So here we go. Everybody, quick question. If I told y'all that, yo, hey, x to the power of, let's say 4. Everybody, what's another way to say x to the power of 4? Like what does that mean? What does x to the power of 4 really mean? Help me out. What does x to the power of 4 actually mean? Like when you see that, right, it's x multiplied by itself 4 times, right? That's x multiplied by itself 4 times. So we would write x times x times x times x. So here's what I want to teach you guys. And this is something that a lot of us intuitively know, but never got it formalized to us in high school because the teacher may not have had enough time. But here's the difference. The positive power means you are multiplying that number by itself that many times. Everybody, what did I just say? A positive power means you're multiplying that number that many times. Everybody, what do you think a negative power means? Does the opposite, Jalen, be more specific? What do you mean there? So if a positive power means you're multiplying that number that many times, a negative power means you are blanking that number that many times. That's right, dividing that number that many times. And so if we're taking a look at this, if we're taking a look at x to the power of -4, well, all we're saying is we're going to be dividing that number that many times. So I'll place 4 of these x's in the denominator. And so allow me to highlight the -4, and you have 4 of them appear in your denominator. That's what a negative power means. That's all it is. A negative power, instead of multiplying that number that many times, you're dividing that number that many times. And so what this would reduce to, or simplify to, if it's in the denominator, everybody, what's the same thing as saying x times x times x times x? What's the same thing as saying x times x times x times x? What's the same thing? What's the same thing? Yeah, x to the power of 4. And there it is. And there it is. So just to recap here and make sure that you understand what just happened. Remember this very, very true principle of positive and negative exponents. A positive exponent. So write this down with me, my party people. So a positive exponent. Oops, right there. You are multiplying blank times. You're multiplying blank times. A negative exponent, you are dividing that many times. You are dividing that many times. That's really it. That's really it. And so when you have a negative power and you need to make it a positive, basically what you're doing is you're moving it from the numerator to the denominator. Or if you have a negative power in the denominator, move it to the numerator, just like that. Seriously, just like that. It is that straightforward. Okay, it is that straightforward. So that's the shortcut. That is the shortcut way to think about it. But I want to just go ahead and show you one more time. Just go through the motions here again. X to the power of positive 4 tells me x times itself 4 times. So x to the power of 4. If you have a negative power, x to the power of -4 means you're dividing that number that many times. And so you'll basically write 4 of those x's multiplied together, but in the denominator because you're dividing them. And so that becomes 1 over x to the power of 4. So if you're looking for a shortcut here, my party people, it's this. The shortcut is, if you have a negative exponent, move the power to where it isn't to turn it positive. So if you're taking a look here, x to the power of -4 is the same thing as saying x to the power of -4 divided by 1. So there's your numerator, there's your denominator. Just move it to the denominator, And there's your shortcut if you are ready to take that shortcut. If you need to divide that number that many times and see how it works out, sure, do your thing. But really a negative exponent just tells you to put that thing on the opposite numerator, denominator, wherever it's not, move it there and make it positive. Yes or no, my party people, does that make any semblance of any sense? Yeah, again, because like if you have that down, I'm telling you, if you have this down, the negatives and the powers to powers, those two together, that's arguably half of what people complain about when it comes to the ASVAB. A lot of people can get the multiplying and dividing the powers down. You got that? But the power to powers, roots of powers, and the negative powers, a lot of y'all get tripped up by that. So with that said, before I continue, as promised, let me go ahead and call on Elijah. Where you at, Elijah? I'm going to find you here. There you go. Elijah, what's going on, boss? What was that question?
So my question is, how do you, in the ASVAB, I mean, it's been 10 years since I've been to high school. So like, this is like a big refresher for me. How do you identify in the ASVAB the laws of exponents in a test? How do you identify it to follow these rules of multiply, divide, and negative, and et cetera, so forth?
Yeah, I got you, man. So when we get into the practice time here, we're going to have a ton of practice problems. We're going to go through at least 40 today. But I'm going to show you question by question how to know that you're applying it. But typically, it's going to be recognizing the action. So if you see that you're like this, if you have two variables being multiplied, then you need to remember that the rule is, hey, we're going to be adding those exponents. If we're dividing those powers, you have to recognize, take those exponents and subtract them. And then over here, if you see a negative power, you got to recognize, okay, I got to move that thing to where it's not. If it's up top right now, then I got to move it to the bottom.
Okay.
All right. And so likewise, everybody, remember what I said. A negative power just means you're dividing. And so if you're looking at a funky example like this one over here, if you're looking at a funky example like that one, well, if you already have a negative power in the denominator, again, like I said, just move it to where it's not. Because if you have a fraction and then you're dividing a fraction, well, dividing a fraction by a fraction means you just flip it. And so here, this x to the power, or y to the power of -3 gets moved up top. Y to the power of +3 over 1. So yes and no, everybody, does that kind of continued explanation make a little more sense for that case? For the case where you might be dealing with, again, a negative power in the denominator. Really, the rule is, the shortcut rule is, for negative powers, exchange it between the numerator and denominator. Wherever it isn't, move it there. And then you can make it positive. That's it. And for someone who asked earlier, I think it was Simone who asked earlier, yeah, it's only going to be the variable itself that gets moved. So here's another example just to make sure that we understand this. If we have, let's say, 3x to the power of -2, everybody go ahead and write this down. In this example, it's just the x to the power of -2 that has a negative exponent. That 3 has its own exponent, so don't even worry about the 3. So what you're going to do is you're going to say, hey, that 3 stays up top, and we make that x squared +2 as the power, but we move it to the bottom and only that. You do not move anything else, only the variables that have the negative exponent on them. Regular old numbers, they stay put. Jose, glad I could answer your question. Shadrach, yeah, that's right. Well, besides that, the roots would probably be slightly harder in terms of how y'all handle them now, but I'm sure that I can make sure that this makes sense by the end of class. I gotcha. So there it is. So take a screenshot if you need to. I'm going to go ahead and call it once, call it twice. Go ahead. 5, 4, 3, 2, and 1. All right, let's get to it. Yeah, Pedro, I got you, man. I got you. So we're going to look at plenty of examples. Don't worry. So here, power to a power and roots of powers. So if you thought that, again, what we just did in the last slide was the hardest thing we'll ever do, this is honestly on par in terms of difficulty but only because, again, we just don't understand what these things actually mean. Like taking the root, the cubic root, the fourth root, the fifth root. I'll teach y'all all of that. I got you. But first off, power to a power. Go ahead and write these down, my party people. Power to a power. Let me go ahead and put that as high as I can. But a power to a power, here's the rule. Write it down. Multiply the powers. Root of a power, divide the exponent by the root. And then there's a key here to this. I would add on to this, leave the remainders inside the root. Very important to know. I would absolutely add this to these notes. Leave the remainders inside the root. Leave the remainders inside the root. All right. And then lastly, another way to think of it in a very intuitive way in English, I would just say, look, bring out as many of the roots as you can. Bring out as many roots as you can. Okay. So I'm going to show you a few different ways as to how that makes sense. I'm going to show you quite a few different ways that I think, again, we're going to appreciate by the end of the day. So I'm going to give you about 10 more seconds here to just finish writing this down, and we are moving forward. We're making pretty good time on notes here, too. I'm open by like about 7:05. Again, we'll take that quick break, talk about the classes for next month, and then I'll have that schedule out by Thursday this week. All right, so that is 3, 2, and 1. We're good. Okay, so let's look at some examples here. So power to a power. Let's take a look at this real quick here. Power to a power, zooming in all the way over here. Let's take a look at what's going on. So again, everybody, what we're looking at right now is an example of a power to a power. I'm going to zoom in a little further so you won't be able to see that up there. You won't be able to see that, but just make sure you write down that this is an example of a power to a power. So everybody, the rule for a power to a power is, what do we do with those exponents? If we have a power to a power, what are we doing again? A power to a power. No, what was the rule that we just wrote down in the last slide? I said, if we have a power to a power, what do we do with those exponents? We said we would multiply them. Again, a power to a power, we are multiplying the exponents. If we're multiplying the power, so multiplying the variables, you add the exponents. So I'm going to teach you the differences between, not really getting confused between noticing you're multiplying the variables or you're taking a variable to a power again. This is what we're looking at here. We're looking at a power to, well, that's way too big. You're looking at a power, close that parentheses, and then you have another power right outside. So yes or no, everybody, do we recognize that we have this right here? We have x to the power of 4 taken to the power of 3. Yes or no, do we notice that? It is literally x to the power of 4 chilling by itself inside of a parentheses, and then you got to the power of, well, for y'all, it'll be right up here, power of 3. Okay, so let me just show y'all. Well, does anybody here, before I even continue, just to, kind of help you understand, how much we can appreciate this? Yes or no, can you solidly and confidently explain to me why that is multiplication? Do you know, confidently, without a shadow of a doubt, how to explain that, yeah, when you get a power to a power, you multiply because blank, blank, blank? Are you confident that you know it, know it, know it? I mean, you might know the rule, but do you know the reason why for that rule? So I love the confidence. I'm assuming that y'all are serious about what you mean here. So here's why, everybody. Question, true or false? When you have an exponent, that tells you to multiply that number that many times. An exponent tells you to multiply that number that many times. True or false? An exponent just means multiply that number by itself that many times. True, right? Okay, cool. Watch this, everybody. Take these notes, man. Take these notes. Right here, watch this. If we have x to the power of 4, then to the power of 3, wouldn't that mean that we're taking x to the power of 4 and multiplying it by itself 3 times. Isn't that what that means? Isn't that what that means? If you're saying something to the power of 3 means multiply that thing by itself 3 times, right? Man, a lot of y'all are saying no. A lot of y'all are saying no. Let me go ahead and put it to you this way. So this is why, again, this is one, I guess I could be more honest about it. This is definitely one of the harder ones. I got you. So everybody, watch this. Let's go ahead and learn ourselves some math. I got y'all. So if I were to write, let's say x to the power of 3, that would be x times x times x, right, everybody? Right, true, sounds good. We're going to fix that right up. All right, cool. So what if we had, let's say, if we had y to the power of 3, that would be y times y times y, right? True or false? Some of you are all like, yeah, huh? Where are you going with this? All right, don't worry, I got you. So let's go ahead and think about this example now. What if we had, let's go ahead and say, let's say we had watermelon to the power of 3. If we had watermelon to the power of 3, everybody, wouldn't that mean that we got watermelon times itself 3 times? Is that not true? Wouldn't that not be watermelon times itself 3 times? Okay, now let me prove the point here. You guys, some of us are missing the picture here. If I'm taking a look over here again, everybody, it doesn't matter what's inside of this. If you got a parentheses and that says to the power of 3, what you're doing, if I went ahead and blocked this out, like if I blacked this out and I just said, hey, I got whatever's in this box to the power of 3. Whatever's in this box to the power of 3. Wouldn't that mean that, yes, indeed, we have x to the power of 4 times x to the power of 4 times x to the power of 4? Is that not true? Is that true or false? Kadeja, I gotcha. So that's the thing. That's really one of the points that I'm trying to make here. I got you, Alex. I got you, Simone. So that's the point I was trying to drive home. I want to make sure that you understand the fundamentals here. If you remember the fundamentals, an exponent just means multiply that number by itself that many times. So if you have a power to a power, what you're saying is you got x to the power of 4 3 times. And the long way to do it is 4 plus 4 plus 4. But the easy way to think about it when it comes to addition, if you're adding the same number 3 times, that's 3 times that number, yes or no? If you're adding that number 3 times, that's the same exact thing as just multiplying those numbers. So 3 times 4. And in this case, that would be x equals 12. That's what we got. That's what we got. So again, this is one of those situations that, again, if you go away from the fundamentals, if you go away from the basic strategy that we learn, it's a lot harder to understand the more complicated things because the complicated things require us to have a good foundation with the fundamentals. So on a scale of 1 to 100, how much sense does this make so far in terms of what I'm trying to convey? Because again, we're going to get into the practice in a bit, but if we don't have the reasons and the fundamentals down, then it's going to continue getting tougher and tougher. So with that said, before I go into this next example with bigger numbers and more terms, I got you. Dwight, go ahead, boss. How we doing, man? And what is your question? I got you. Let's be specific about what we don't got.
Yeah, good afternoon, coach. What are you going?
What's up, man? How we doing?
There, man, try both made, but more ask a question, coach, right? So when you do it, if it's the 4 up at the top and the 3 outside, you have to multiply the 4. You have to do you have to multiply it like 4, like the 3 times. That represent like you have to multiply it like 3 times, coach.
Yeah, that's a shortcut rule. So when you have a power to a power, what you're going to do is you're just going to go ahead and multiply those powers right there. 4 times 3, and then that's going to give you that final answer.
So that means that the 3 mean that the 3 is showing me that we got to do the 4, the 3 be showing us like we got to do it like 4 times 4 times 4, coach.
No, that'd be 4 plus 4 plus 4. So, which is the same thing as saying 4 times 3. So remember, Dwight, the same thing. If you're adding the same thing a bunch of times, you can save yourself a lot of time. Because here the rule would be add those exponents together. The rule would be x to the power of 4 plus 4 plus 4. But instead of adding 4 3 times, you can just say that that's the same thing as saying 3 times 4. Same thing. And that's how we get that 12.
Yeah, coach, but this the thing is it, coach, I'm not gonna lie to you. I see some more serious one on the practice test than this, coach. You know what I say? It much like complicated than that, coach, to be honest.
I got you. Hey, we're gonna work on it. I got you. But the thing is, think about it like this. When you learn how to drive, did someone just put you in a very nice car and told you to drive on the highway? Probably not, right? Yeah, so we got to take it slow. We absolutely got to take it slow so that way we can understand the mechanics and then recognize what to do when we set something crazy like this.
All right.
Yeah, I got you. So with that, man, thank you for the question, Dwight. But remember, when it comes to powers, we are multiplying those powers. Okay, who just keeps calling me? Sorry, do not disturb. All right, so let's go ahead and get this going, my party people. Let's understand this bigger example now. So here's what we have. We have all of this in a parentheses. And then we're taking it all to the power of 2. So everybody, what we said is when we take a power to a power, well, we multiply those powers, right? Now, what do we do when we have 2, x cubed, y, right? What do we do? Well, the thing is, that's all bunched up together. Those are all being multiplied together. And so really what you're doing, I'm going to show you 2 ways here, but really what you're doing at the end of the day is you're going to, quote, distribute the power. All right. This sounds a little counterintuitive, but what you're doing is you're going to distribute the power in this way over here. The 2 is going to go up here with the exponent, there, and there. So let me rewrite this. What we would have is going to be 2. Everybody, question. Right now, I don't see a power on 2. If I don't have an exponent or a power on a number, what power is always there? Yeah, there's always a 1 there. So this is technically going to be 2 to the power of 1. And when we bring that 2 from over here, that's going to be times 2. Because again, a power to a power, multiply those powers. What do we have with the x cubed? Well, what we'll have is it'll get multiplied by the 2 as well. And then we have the y, and that's going to be to the power of 1, but that's going to be multiplied by 2. And so with that said, my party people, what are we going to have here? We're going to go ahead and have, come on guys, keep it focused there in the chat box. Keep it focused in the chat box. So yeah, everything, we're just going to go ahead and multiply those exponents and we're done. And that's it. Straightforward. Straightforward, all right? So what we have here is 2 to the power of 1 times 2, which is 2 squared. Then we have x to the power of 3 times 2. Everybody, what's x to the power of 3 times 2? X to the power of 6. X to the power of 6. And then what's the y going to have as the power? Right, y to the power of 2, exactly. And so is there anything that we can simplify here, everybody? Is there anything we can simplify? Anything at all? Is there anything we can simplify? Yeah, I would say we can simplify the 2 to the power of 2. Because everybody, 2 to the power of 2 or 2 squared, that's just what? That's just what? Right, 4. 2 times 2 is just going to be 4. 2 times 2 is just going to be 4. So we can turn this into 4x6 y2. Or 4 times x to the power of 6 times y squared. Now, I'm expecting this to make sense to about 75% of the folks in here. About 75%. I'm going to show you another way you can think about this. This is the longer way. But again, this is why this works. Let me show you why this works. Dwight, none of that in class, please and thank you. So with that, stay focused up, guys. Come on. With that, let me go ahead and move this right over here and show you another way to get this done. Let me show you another way. So everybody, question. When we have 2x cubed y, all of that to the power of 2, all of that to the power of 2, when we have that going on, everybody, the power of 2 means we should be doing what? Again, an exponent of 2 just means what? In your own words, an exponent of 2 means what? So we're saying it in shorthand. I want you guys to give it, not multiplied by 2. An exponent or a power of 2 means what do we do with whatever is in the base? Not doubling it, not doubling it. You're multiplying that number twice. Exactly. You're multiplying the number 2 times. You're not multiplying by 2. You're multiplying the number 2 times. And so what I want to express to y'all is this. This is the longer way to look at it, but this does make sense at the end of the day. When you're looking at it this way, what we have is this. This turns into 2x cubed y times 2x cubed y. That's what ends up happening in that sense. So let me go ahead and just kind of mute this. I don't know why I'm getting like 17,000 calls right now. It's all good though. There we have it. Okay, so that's what that looks like, right, everybody? That's what that turns into. And the thing is, again, squaring something is just multiplying that thing by itself twice. So here's why this works again. Right over here, I can get rid of these parentheses because there's nothing blocking it, nothing in the way. And I'm looking at this and I'm saying, yo, hey, everybody, what is 2 times 2? Help me out. What's 2 times 2? Okay, that's going to be 4. Okay, when I look at over here, x to the power of 3 times x to the power of 3. Everybody, what do you do again when you're multiplying the same variable? What's the rule again? Who knows what the rule is? Write it out. Don't give me the shorthand. Don't give me the shorthand. Add what? Add what? Add what? Be specific, guys. Be specific. Add what, man? Add the exponents. Yes, add the exponents. So in this case, we have ourselves 3 and 3. So we should write x to the power of what, everybody? X to the power of 6. All right, and lastly, we're multiplying over here. We have y times y. Everybody, what's the power on the y? Like, what's y times y? What's y times y? Yeah, the power is 1. So what's y times y then? Y times y is going to be, stop shorthanding it, guys. Give me what? Y squared. Yeah. A lot of y'all are just saying 2. Yep, just 2. Again, we have to be engaged here. We have to be meticulous about being proper. All right, guys. And because the thing is, look, when you focus on the little details, the more you're going to remember the bigger picture. But the less you care about those little details, I'm telling you, it's going to reflect in those results. It's going to. They're not grading you on explaining your work, but being able to explain your work is required if you expect a high score. So here we go. That's going to be y to the power of 2. So that's another way to look at it. Again, this right here was a shortcut. That was a shortcut. Oh, if you have a power to a power, just multiply the powers. But really what that means is you're multiplying the powers because you're writing whatever's in there this many times. And so that is that's the longer way of saying multiplication. It's all good, Tana. So yeah, we still get the right answer. We still get the same exact right answer right over here, right over there, right over there. Still the same exact right answer. Same one. So for anybody that was confused before, is it making a little more sense now? Is it making a little more sense now? Krishan, let me know. I saw that you had questions about it still. Much better, Krishan. Hey, let's go. Let's go. Let's go. Let's go. Natavia, don't worry, Natavia. We're going to have plenty of examples to go through. I got you. Elijah, same with you. So where did we get the 2 from? For the y? So the 2 came from this. When you look at anything that doesn't have an exponent, the exponent is always 1. So the exponent here is a 1 and a 1 right there for the y. And so when you multiply the powers, 1 plus 1 is 2. Cool. So Tama asks, hey, So coach, is that how you would check your answer to see if it's correct? That's the long way to do it. Yeah, you can absolutely check your work that way. You can always do it the long way to see the short way, the shortcut made sense. So if you're still confused, don't worry, because we're going to go through plenty of examples. I got y'all, because we're going through 5 different sets of rules. So the last one, but honestly not least, the last but not least is this. In case you haven't heard, I have an ASVAB program that's meant to help you raise your score wherever you're at. And here are 3 great reasons to go ahead and consider it right now. 1, you get all of my classes. 2, you can text me whenever you need help. And 3, you can't beat the price. I can promise you right now, if you click the link in the description of this video or somewhere around here, and you go ahead, watch how it works and look at the price, I'm pretty sure your jaw's gonna drop. It's actually 24 hours of classes a month plus everything else that you get with it for less than $60. So with that said, go ahead and check it out. I'm Anderson, your ASVAB coach, and I'm proud to help you ace the ASVAB. Let's get to it so we can get that job we deserve. Check it out now. But until then, if you say no, it's all good. Let's get back to the learning here and let's keep crushing it. The root of powers. So here's how I'm going to express this. This is the beast of the day, okay? Let me go ahead and ask y'all some fair questions just to kind of gauge where we're at. And then we're going to tackle this nice and easy. So my first question, everybody, when it comes to, like, here's what we went over so far. So when it comes to multiplying variables, everybody, are you aware that we are going to be adding the exponents? Yes or no? Multiplying variables, add those exponents. Yes or no? Okay, sounds good. So when we are looking at dividing variables, are we aware, and do we have it down in our notes, that we should be subtracting the exponents? Are we aware that we should be subtracting those exponents? Okay. Again, it's okay to say no. Because again, if some of us came later or didn't quite catch the notes or didn't quite make sense, that's okay. Just being, again, honest dialogue here. That's all it is. Now, are you aware that when you have a negative exponent, you can make it positive by basically flipping it? Numerator to denominator, denominator to numerator. Are you aware that if you have a negative exponent, you can just go ahead and move it to where it's not, up or down, nice and easy. And only the variable with the negative exponent, not anything else associated, just the variable with the negative. Okay, so number 4 of what we've gone through after that was power to a power. So power to a power. So are we aware now that the shortcut way is, hey, power to a power, multiply the exponents from the power with the power outside, with the exponent outside. Are we aware of that? Let me go ahead and just fix that chicken scratch. So power to a power. Okay. Yeah, you move the variable to Felix for sure. Yeah. And so I had totally messed up right there. Thanks for pointing that out. There's number 4. And so here's what we're doing right here for number 5. For number 5, what we're going to be doing is now the root of a power. Okay. So this is the hardest one. But let me be very clear with you. If you have numbers 1 through 4 checked off, like, okay, I have these rules written down. Like, I'm not asking you to be perfect. I'm not asking you to be flawless. All I'm asking is, do you have the notes for these? And are you ready to tackle some practice problems with me? And then eventually do some on your own. Like, that's what I'm asking with those first 4. If you're feeling good about those, then here, number 5, this is where things are going to go ahead and be like, oh my God. Okay. So just making sure that we're secure here in those first 4 before we go into the war zone here for number 5. All right. So everybody remember, a power to a power. What did we say the rule was? What do we do with those exponents? A power to a power. Help me out again. I'm just, short-term memory loss. I forgot what y'all said. I forgot my own notes. When I'm taking a power to a power, what do we do with those exponents? Yeah, we multiply those exponents, right? Okay, sounds good. Okay, let's go ahead and freshen up here. Let's get to work. Everybody, a root of a power is the opposite of a power to a power. So if a power to a power, you're multiplying those exponents. What about the root of a power? What do you think? What operation do you think is happening there? Yeah, you will divide. You're not going to divide exponents. You're going to divide what's called an index, or the root. But we're going to talk about that in a moment. I got you. We will divide by the root. So again, these are opposites. Power to a power. You multiply the exponents right over here. Multiply exponents. Here, for the root of a power, what you're doing is you are dividing the exponent by the root. You are dividing the exponent. Divide the exponent by the root. Okay? And so let me just remind you about what I said earlier. So again, for root of powers, divide the exponent by the root. So I told you right here, divide the exponent by the root. It is verbatim stated right there. But there's a caveat that I gave you here. Please make sure you have this written down before I continue. Leave the remainders inside the root. One more time. Leave the remainder inside the root. Write that down. I promise you, if you have that written down and you look back on this when we're practicing, you'll be like, yo, this didn't have to be as hard as it was before when I took this in high school or tried this for the GED or tried the ASVAB before. This actually is not really that hard. Watch, I got you. For sure, Armani, I got you. Take a quick picture, Armani. You got this? And enough of my farmers only profile picture. Let's go ahead here, and hopefully that was enough time, Armani. Sounds good. So let me go ahead and give you guys a chance to really work with me on these here. Let's go ahead and get started. So here, what do we have here? We have this, and just ignore this. Don't worry about taking this down. Don't worry about taking all this down. Do not worry about all this. Stop. Okay? Put your pencils down. All right, everybody? Put your pencils down. Put your pencils down. So first question I'm going to ask you is this. Sometimes we see roots where there is nothing written in terms of you can have this, that's called the square root. You can have a cubic root. You can have a fourth root. You can have a fifth root. So this right here, everybody, I'm telling you, this is all called the root. Those are called roots. Okay? So it's all good, guys. It's all good because I'm going to show you how easy this can actually be. I'm going to show you how easy this can actually be. So watch this. Everybody, all the way on the left over there, all the way on the left, the one that doesn't have anything in the index, the root, what is that going to be? What number should belong there? Look at the pattern. What should belong there? Yeah, a 2. It's going to be a 2. Now, let me help you understand why. Remember that this means square root. Square root. So basically, it's the same thing. Square root is a root with a power is a square root. The power is 2. So square root just means a root of 2. Now, the reason that we don't write the 2 all the time is that for the same reason of saying, hey, why don't we just say 1x instead of x? It is 1x, so you don't have to repeat it. You don't have to be repetitive. If that's called the square root, you don't have to put the 2 there because the 2 is saying square root. But that symbol in and of itself means square root. That's third root, fourth root, fifth root. But for the one without it, it's assumed that it's square. It's assumed that it's a 2. Yeah, it's assumed that it's a 2. So for the same reason, again, like I said, and the same thing is saying, hey, 1x and x, saying 1x is just redundant. Saying this right here, saying, oh yeah, the second root of this number. No, we just call that the square root. That's what that symbol means. That symbol means square root. There is a 2 there that we don't have to repeat. Same thing if we were to say, x. Well, x is the same thing as x to the power of 1. We don't always say x to the power of 1. We don't say 7 times 5 as 7 to the power of 1 times 5 to the power of 1. No, we just say 7 times 5. It's redundant and repetitive and unnecessary to say, just like this. So one more time, just got to make sure, you know me, I got to make sure we solidify the fundamentals. If you see a root, that symbol just like this, there is a 2 there. It's just redundant to say. Okay, that's the last I'll say of that. Well, we're going to bring it back, obviously, in a couple moments. But now let's understand what this all actually means. So everybody, quick question. Let me go ahead here and give ourselves, so actually I can go over here. Yeah, I'm gonna affirm right over here. So I better learn this. I got you, Tony. No need to threaten me. I got you. I got the credentials. So here we go. So everybody, question. Let's just look at some of the stuff that we do understand. If we looked at the square root of 9, quick, what's the answer? Square root of 9 is what? Square root of 9 is 3. Oh man, some of y'all are pretty okay. Some of y'all are pretty confident about that. Sounds good. And you're correct. But why? Let me show you how this works, how the root of a power actually works. Everybody, isn't it true that 9 is the same thing as 3 squared, right? Isn't 9 the same thing as 3 squared? Isn't it the same thing? Also, everybody, isn't it true that the root, what number belongs right over here, everybody? What number belongs right there? What's the root here if we don't see a number there? Yeah, the root is 2, the square root, like feet squared, right? Square root. So we have a root of 2 here. And so we have our 3 squared. And now the last and final question, my party people. What was the rule for taking the root of a power? What operation did we say it was? If we're taking the root of a power, what did I say we should do? Yeah, we will be using the operation of division. We will be dividing, and here's how that works. What will happen is this, everybody. What will happen is we will have 3 to the power of 2 divided by 2. Everybody, what's 2 divided by 2? Hardest question of the day. Damn straight. That's going to be 3 to the power of 1. 3 to the power of 1 right over here. 3 to the power of 1. And everybody, isn't 3 to the power of 1 the same thing as just saying 3? Don't we have to be, if we kept it simple, isn't it just 3? Right? Same thing. Same thing. Same exact thing. So we know this as, oh, what number times itself gives us 9? 3. But really what's actually happening is, look, 9 is the same thing as 3 squared. If you're taking the square root of a square, it kind of cancels out, leaving you with the root, the 3. Okay? Now, what I want to show you here is this, my party people. It's this. I want to show you the example that we just looked at. And that's going to be the square root of x to the power of 6. Let's go ahead and show you that right now. So here's the previous example. I'm going to leave that right there for as long as I can. But let's say we're taking the square root of x to the power of 6. Everybody think of it like this. If we're doing the square root of x to the power of 6, everybody, what belongs in here again? What belongs in there again? Oh, 2. That's right. So everybody, look at this. What is it going to be here? I'm going to follow the rule. Divide the exponent by the root. So we have x to the power of 6 divided by 2. Everybody, 6 divided by 2 is what? That's going to be 3. And so what we receive here is going to be x to the power of 3. And that's why, at the end of the day, when we take the square root of 6, of x to the power of 6, it's going to be equal to x cubed. Because you divided the power by the root. That's really what I have to do. Divide the power by the root, because what you're saying is, yo, hey, how many perfect squares do we have in there? That's what you're asking. How many perfect squares do we have in there? Here's an alternate way of thinking of it. Here's an alternate way to see it. I'm going to be really focused and zoned in on this for the next 5 minutes, because I really want to make sure that there's at least one of the different angles that you see that I'm showing you. One angle is this. One angle is, hey, what you're doing is you're just going to follow the rule, divide the power by the root that you have, and you're good. The second way to look at it is going to be, hey, notice that we are dividing the power by the root, but what we can also see is this. Let me use purple. If we have the square root of x to the power of 6, everybody, if we had a perfect square would that reduce? So let me go and ask y'all this. If I said, yo, hey, the square root of x squared, everybody, what's that going to be? If we have the square root of x squared, what's that going to be, everybody? Humor me. Right, it's going to be x, right? That's going to be x. If I looked at the square root of 5 squared, that would be 5. If I had the square root of 100 squared, that would be 100, right? The square root is the opposite of squaring. So let me ask y'all a nice and easy question here that might make this a little more understandable. Watch this. Nice and easy. Isn't it true that x to the power of 6, isn't it true that x to the power of 6 is x to the power of 2 times x to the power of 2 times x to the power of 2? Isn't that true? Isn't that true, everybody? Right over here. Isn't that true? Well, it is true because remember, when you're multiplying variables, you just add those exponents. So that would be x to the power of 2 plus 2 plus 2. That would indeed be x to the power of 6. Now, what am I getting at? What am I getting at? Well, what I'm getting at is this, my party people. What I'm getting at is, yo, hey, take the square root of x squared. Everybody, what's the square root of x squared? X, okay. Everybody, what's the square root of x squared over there? Okay, okay, that's gonna be x. Okay, one more question. What is the square root of x squared gonna be? Oh, okay, that's just gonna be x. Okay, if we have x multiplied by itself 3 times, what's that gonna be? That's gonna be x to the power of 3 because you have the same number multiplied by itself 3 times. So that would be x to the power of 3. And that would be our answer. And that would be the answer right there. Right there. Both ways. No way. Get out of here. Sounds good, Simone. I'm going to get out of here. I'll see you guys later. You guys be easy. But that's just another way to look at it. That's just another way to look at it. So on a scale of 0 to 10, I'm not going to ask you, how confident you are, but how comfortable are you with what we just did? Bruh, coach, where were you in 2017? Let me ponder that. Where was I in 2017? I was just starting graduate school. 2017, I was teaching teachers. Maybe I was probably near Chipotle, most likely. Yeah, back then I was ordering the double chicken with some steak in there. Yeah, probably. All right, so let's go ahead and keep it going here. So, Simone, you're lucky I like you as a person because you would have been out of these classes a long time ago with that attitude about Chipotle. So here we go. I'm in Florida. So here we go. That's the rule there. Again, when you have the root of a power, you divide. Now, the one thing we haven't gone over yet are some pretty crazy examples where we have something to this effect, where we have the third root, a cubic root of x to the power of 4. But allow me to show you how to do this nice and easy, everybody. Allow me to show you how to do this nice and easy. If I'm taking a look at the cube root of x to the power of 4, I want you guys to take a guess at what you think the answer is. I'm going to give you, everybody here, I'm going to give you all exactly 1 minute to tell me what you think the answer is going to be. So here's a minute on the board, and I'm going to put the timer up right now. Okay. So I'm going to give you a minute to go ahead and tell me what you think the answer might be. Go ahead. Time is up. Time is up. Let's go ahead and try this out. Let me get that timer out of the way. Thank you, sir. All right, let's try this out. So here's the thing. I'm going to show you a couple different ways of looking at this, and then we're moving forward no matter what. So here's the thing. If we're looking at the cube root of x to the power of 4, everybody, what are we dividing the exponent by? What are we dividing the exponent? Oh yeah, we're dividing the exponent by 3. Absolutely. Now my follow-up question is, well, what did we say we would do to the remainders, everybody? What did we say we would do to the remainders? Leave it in the root. Exactly. We told ourselves we would leave the remainder in the root. Leave it in the root. And so think of it like this, everybody. What you're saying is the cubic root of all of this, you're basically looking for a number that can multiply by itself 3 times. And so what I see from this is I see that I can write this as the cube root, not of x to the power of 4, but of here, x times x times x times x. Because what I want you to notice is this, everybody. If you're taking it nice and slow, what you might notice and realize is that you have 3 of them right there. You have 3 of them right there. And so what you can rewrite this as is the cubic root of x cubed times x. So everybody, which one of those, the x cubed or just the regular x, which one of those can have their exponent divided by 3? Which one of them can? Which one of them can? Yeah, the x cubed. That'll be a nice solid 1. 3 divided by 3 is 1. That is nice and solid, and we're good. Go ahead, take that right there. And this is going to turn into just a regular old x, because it's going to be x to the power of 3 divided by 3 times the cubic root of just x. But everybody, what do we know? We know that 3 divided by 3 is just going to be 1, right? 3 divided by 3 is just going to be 1. And so, yeah, what's going to happen is this just turns into x times the cubic root, not cubed. That is not x cubed, okay? That is not x cubed. That is the cubic root of that x that stays right there. That's what we have. And so notice the remainder stayed inside. We had x cubed that was a perfect match here, and that extra x, just leave it inside. Only the party people that are matching up can leave. So if your exponent is divisible by that number, great. If it's divisible by the root, take it and you're set. Now, again, I don't expect everybody here to be all peachy. This is not the easiest one. And, you know, even with all the teaching experience in the world, there is a slight gap if you're just starting off in a certain area for the ASVAB. So I'm just doing my best here to convey the messages, give you shortcuts, but also show you how to responsibly tackle this and understand this. Okay? So the answer there is, again, yeah, that's the answer. And in case you didn't notice, when I was asking the question to y'all, the answer was given to y'all the whole time. It was right there the whole time. And I was like, all right, I'm going to give you a minute to give you the answer. It was right there. It was right there the entire time. I knew a lot of y'all wouldn't recognize it. I knew it, but it's all good. I know. I know. So with that, let's go ahead here and let's go through our guided warm-up. But before we do, I know it's 7:20 and I promised I would do this well beforehand. Let me go ahead and just do this. Okay, everybody. So a quick little thing before we continue. 2 more hours. Oh gosh. So 2 more things. Yeah, root of powers. I got you. Go ahead, take a screenshot. But everybody, I gotta go ahead and ask y'all a couple of questions here because, again, it's the end of the month. It's in the end of April. We got May right around the corner. And you guys know that I'm always going to be transparent with y'all and honest with y'all about things that I want to try, things that are coming up, and any vacations that I may have lined up. So let's go ahead and just give you guys a lowdown real quick about next month. So first of all, before class started, a lot of y'all answered this question already, but I got to ask again, now that everybody's here. My question is this. Would you guys be excited to see a class where I don't go over a specific topic, but I go over basically a test-taking strategy for the first half, and then the second half, we go over different test-level questions where I go over how to apply those strategies. So not exactly a specific topic, but any topic for math or math knowledge or arithmetic reasoning, and how to apply and how to stay calm, cool, and collected. Okay, sounds good. Sweet, sounds good. So I'll go and write that down. It looks like you guys are excited about it. Okay. Sounds good. Now up next, another question that I had was, how do you guys feel about having a class? So I've done this in the past before where I did those advanced classes where I told you, hey, if you want to bring a calculator, bring one, because what we're focusing on is the straight up setup. So everybody, question, for those of you who did come to those classes before, would you like to see those come back? Where we're looking at, again, just learning how to set up the word problems and make sure that we know that we can explain how the problem works. Not focusing on the calculations. We speed that up with the calculators, but we just focus on the setups. It works? It worked for you, Simone? Okay, sounds great. Okay, so advanced classes are coming back. All right, and last one, notice how we've been releasing these speed drills in the math bootcamp. So if you are in the program, let me go ahead and actually, for those of you that are interested in the program, because I haven't mentioned it yet, but go ahead and check out the chat box. If you are interested in the program, this is how you can get all of my resources, thousands of extra practice problems, a bunch of video solutions, like 1,000 at this point. There's a ton of stuff out there, but here is the link to the full program in case you wanted to check it out and you're here for free today. This is my full program. You get all the classes and everything. But for those of you that are in the program and in the math bootcamp, you've seen those questions there that give you the opportunity to test yourself out speed-wise, timed. Would you guys like me to bring those speed drills here, where we go over literally just sets of 10 questions at a time, and we're just drilling one specific topic, one specific action, like solving equations, like solving proportions, reducing fractions, multiplying decimals, dividing decimals. Like, we will just straight up attack one topic at a time. Here is the chat box. Go ahead again. Would you guys be excited for me to bring those speed drills here? Where it's literally going to be exactly what you're doing in the boot camp, but live with me. I take you through an exercise all the way through for 2 hours, and by the end of those 2 hours, we have this down pretty much. Yeah, sounds good. So get ready. These are going to be program classes only. I am going to test it out next week with solving equations on Monday in the free class. But beyond that, after I do the pilot class with everybody for free, this is going to only be included for those in the program. So speed drill classes. Those are the 3 things that I had in mind for next month. All right, everybody. So one thing I've been trying to do is just connect with you all more lately, because of those of you who know me very well, you know my contract situation with that other company, and I'm loving, helping them out, but it did cut into a big piece of this here. So that's why I brought in Coach Gina and Isabella, my assistant, to help communicate with y'all, but I needed to find that balance. And part of that is making sure I keep y'all excited about things like new classes. So also Memorial Day weekend, everybody, Memorial Day weekend, that's the end of the May, but I will not be teaching that Monday in observance of Memorial Day. So I will not be teaching that Monday for Memorial Day. I will still do 3 classes that week, Tuesday, Wednesday, Thursday. And the other thing, in the middle of May, I will be on vacation. You guys know that I do need that time off to go ahead and reset my brain. So I will be on vacation in the middle of May, specifically the week of May 16th. I will be gone the entire week, but we will still have 3 classes. Coach Sheena will be leading the way. All right. We will be doing our 3 word knowledge and paragraph comprehension classes. And what I'm going to make sure happens is Coach Sheena has a brand new set of paragraph comprehension questions and word knowledge questions ready to go for you. Okay. So again, I will be gone May 16th to the 22nd. Okay. I will be gone that week. Actually, Dwight gave me the inspiration. I'm actually going for 5 days. I'm going to be landing in Kingston, Jamaica, and I'm going to be out there for a whole week. Yeah. Dwight gave me the idea. My significant other, we were talking, and she was like, I have a whole week off. What do we do? And I was just like, yeah, I'm on. And then we got it. We made it happen. So boom. Yeah, I'm gonna be going up. I'm gonna be going up to Ochi, so it's about an hour away. But yeah, so enough about that personal stuff. Let's go ahead and get back to the action, my party people. Appreciate y'all. So let's go ahead and have a little guided warm up here. So before we begin, everybody, what are we doing, everybody? What are we doing? Are you from Ochi, Demario? There we go. All right, so what are we doing, everybody? What are we doing? Are we multiplying variables? Are we dividing variables? Do we have negative exponents? Are we doing powers to powers? Or are we doing roots of powers? which one of these are we doing? Which one of these ideas are we talking about in the present? This is the first step, everybody. Again, recognize, memorize, apply. We recognize here, so this is for y'all earlier who are worried about being able to point it out. Elijah, I got you. So earlier, Elijah was like, "Yo, how do we recognize what we're supposed to be doing here? What are we looking at?" And so a lot of y'all look at this and say, "Hey, I have the 7x squared times 4x squared." We are multiplying variables. And in case you weren't paying attention, there it is right there. And so what do we do? What do we do when we're multiplying the powers that have the same base with the same variable? What do we do again? Yeah, we add those exponents. That's right, guys. Everybody. Yep, exactly. So let's get to work here. Number one. Everybody, what do we do with the regular numbers in front? The 7 and the 4, what do we do with those? Yeah, we just multiply the regular numbers. Regular numbers, you just straight up multiply them. So you got 7 times 4, so that's going to be 28. 7 times 4, 28. Sounds good. Next up, we have x squared times x squared. Everybody, what do we do with those exponents again? Just being annoying one more time. Yeah, we add those exponents. That's right. Add those exponents. That's going to be x to the power of 2 plus 2. And that's going to give us 28x to the power of 4. Booyah. Next up, let's get to number 2. Or not really. This is where I'm going to allow y'all to practice what you got here, my party people. So I'm going to set a surprise timer here. I'm going to give you 2 minutes. I only expect you to try 2 of them out. If you get the rest of the 5 done, great. If not, no shame. I'm not going to disown you because I'm not your father. So here we go. Try this out and let's go. All right. So here, number 2, we have 2x to the power 4 times 6x cubed. So let's get it done. What I got here, 2 times 6, that's going to be 12. And then x to the power 4 times x to the power 3. Be annoying, everybody. What are we doing with those exponents? Add those exponents when we're multiplying variables. So there we go, x to the power of 7, and we're done. So I'm going to expedite the process just ever so slightly here. So what we're going to have here for number 3, 8 times 4 is 32. And then we have x cubed times x. Well, everybody, remind me, what power is there on the x if I don't see a power? What did I say? Yeah, there's a 1. There's a 1. And so what we're going to have is x to the power of 3 plus 1, which is 4. 32x to the power of 4. Anybody flawless so far? Anybody flawless so far? Okay. All right. We flossing here. All right. Sounds good. So here we go. Number 4, we got 7x to the power of 4, 6x to the power of 3, 7 times 6, 42. X to the power of 4, x to the power of 3. Add those together. That's going to be x to the power of 7. Okay, cool. Next up, we're going to be checking out this next one here. We have 4 times 2. That's going to be 8. K cubed times k squared. That's going to be k to the power of 3 plus 2, which is 5. Great. And then lastly, we have number 6 here. Number 6, what we have going on here is going to be 6 times 7. So 42 again. And then p cubed times p cubed. Add those together. That's p to the power of 6. Add those exponents together. So 42p to the power of 6. And so we have these bonus questions. And so I'm going to go ahead and just calm the nerves here. So we have 3x to the power of 6 times 9x to the power of negative 2. This would end up being 27x to the power of 4. As the thing is, remember, everybody, you add the exponents. 6 plus negative 2, that's just 6 minus 2, that's 4. That's 4. Nice. Next up, with the second one in purple, let me go ahead and torture you a little more. You can go ahead and actually just start off by bringing these together. So that'll end up being x to the power of negative 2. but then all of that is being brought to the power of 2. So that ends up becoming x to the power of -4, or 1 over x to the power of 4. Either way. But that's what the answer would be. You thought what was the letter B? Oh, 3x to the power of B? Man, come on. Did I use any variables in the exponents yet? Come on now. Come on now. You gotta come on. My handwriting ain't that bad, homie. Chill, man. Chill. Y'all be trying my life, man. All right, so here we go. Let's go ahead and get started again. Dividing variables. I gotta speed up the process just a little bit, Elijah, I'm gonna try to take your question, and then Dwight will try to take yours right after, but I do gotta speed up just a little bit here. So let's go ahead and go through this first set here. Let me go ahead and take care of this one right here. Number 2 for us, and then we're gonna go forward from there. So we got 6x squared divided by 8x squared. Everybody, what's gonna happen with the x squareds? What's gonna happen with those x squared? They're gonna cancel out. Because the thing is, remember, what you do with those exponents is you subtract them. But if you got the same exact exponent, that's gonna cancel out. That's gonna cancel out in this case. And so what we're gonna end up having is just 6 divided by 8, which we can simplify because everybody 6 and 8 are both divisible by what? They're both divisible by 2. Divide by 2, divide by 2. And so we'll end up having 3 over 4. 3 over 4 in that sense. If we're taking a look at, let's go and say number 5. So here's what's gonna happen with number 5. So a better look at this one. There's 2 ways you can really look at this, everybody. There really are 2 ways. Everybody, the main rule, what do we say the main shortcut rule is? What do you do with those exponents when you're dividing variables? What do we do? That's right, we subtract those exponents. That's right, absolutely. Absolutely, so here's what we do, everybody. What we're gonna do is this. And you would end up having p to the power of, what power is here again? What power is there again, everybody? Yeah, that's gonna be 1. And so we have 7p to the power of 1, so that'll be 1 minus 4. That's a little weird, because everybody, question. 4 minus 1 is what? What's 4 minus 1? 3. 4 minus 1 is 3. So if you go the other way, what's 1 minus 4? -3, right? 4 minus 1 is 3. 1 minus 4 is -3. If you just go the opposite way, it's gonna be -3. But here's the thing, everybody. We got this going on right here. We've got 7p and p to the power of -3. Now, if we want to turn that into a positive exponent, what do we say we would do, everybody? We would flip it. We would put it to where it's not, because remember, if a positive power means you're multiplying that number that many times, a negative power means you're dividing that number that many times. And so this is the same thing. Let me use a red little highlighter here. This is the same thing as saying 7 over 2p to the positive 3 power. Again, a negative exponent, you are dividing that number that many times. If you have a positive exponent, you're multiplying that number that many times. And so, yep, nice and easy, we can take care of that. But I'm not satisfied with that, because here's the thing, everybody. I taught y'all the other way to look at it. The other way to look at it is you're essentially canceling variables out. So allow me to do this, everybody, to give you an easier time. 7p to the power of 1 is just 7p. Now, 2p to the power of 4, that's 2 times p 4 times. So everybody, how many of those p's are going to cancel out? One of them. And so what we can really say, just to kind of make things simpler, is you can just say, hey, that cancels out right there. And so we end up having 7 over 2 times p 3 times, which is the same thing as saying, hey, 7 over 2 times p to the power of 3. So again, same deal. But I bet you one of these is probably a lot easier to think about with mental math. A lot easier to think about this second way when you have the negative that's going to be basically happening. If you have a negative that's going to occur, just think about canceling. So instead of doing the 1 minus 4, you can just do 4 minus 1 on the bottom to give you 3. Because it's really all about canceling. Yeah, it's really all about canceling in this case. So again, the shortcut method compared to the intuitive way, again, it's up to you. I need you guys to do the intuitive way more often than not. You are supposed to be doing the intuitive way as many times as you need to until you're ready to use shortcuts. But if you don't know the intuitive way, then these shortcuts probably are a little confusing. That's okay. That's okay. But we have to commit to learning why these things can be taken faster. Okay? So with that, what I want to do here is I want to give you, well, the rest of these problems here aren't exactly challenging at the very least at all. So what I want to do is I want to move forward here into, the mixed practice because it is already 7:40. So here's what we're going to do with my party people. We're going to get into the mixed practice and I'm going to show you a mix of problems. I'm going to give you 2 minutes to try out as many as you'd like. There's going to be 5 per page. And what I expect you to do is this. Don't just go ahead and just dive on in and run your head through a brick wall. If your head's that thick, well, you should consider a different career. But I'm assuming it's not. So we want to go ahead and make sure that we dive in the way that we feel most comfortable. What I want you to do, what I want you guys to do is I'm going to show you the 5 problems, like so. And I'm going to get my big old head out of the way, don't worry. But what I want you to do is observe which one you think would be the easiest one for you to do. Observe which one might be the easiest one for you to do and start there. Then do the second one, then the third one, and then you keep going from there. I'll go through all 5. But what we're going to go ahead and start off with is I'm going to show you 1 page. You'll give your answers. I'll go to the next one, the next 5, and then we'll go back and do all 10 questions. Okay? So here we go. Let's start this practice. Man, I am running out of time. Let's go ahead and practice here. And let me get that timer. And there's the timer. Let me move that over there. And let me make my big old head disappear. All right, cool. And that time is up. All right, time's up. So how are we feeling, everybody? How many were you able to get done? How many were you able to confidently get done? Okay, sounds good. So I'm gonna go ahead and give you another shot, give you another round of 5, and just do your best. Do your best, and then we'll go over all of them together right there after this second timer is up. I got y'all. So here we go. Here's the next one. Let me reset the timer. Okay. First, let's go through number 1. So this one is, let me get the timer out of the way. All right, and goodbye. All right, cool. So this first one here arguably might be one of the, it could be simple, could be hard, depending on how, used to this you are so far. So if I'm checking this out, everybody, think of it like this. First and foremost, isn't it true that 64 can actually be taken out here, right? What's the square root of 64? 8 for sure. Yeah, because 64 is 8 times 8 or 8 squared. So you can bring that out. Yeah, that's going to be equal to 8. And then we'll have the square root in here. Okay. Now, everybody, what do we need to have to get out of a square root? What kind of a number do we need to see to get it out of a square root? We need to see a square. You're saying 2. I'm assuming you mean square. And yeah, that's the case. So everybody, we can look at the k to the power of 3 as this. We can look at it as k squared times k. That's how we can see it. Because remember, the k squared is what can leave. This k squared, remember, the square root of a square is just the number. So if you're taking the square root of 25 or the square root of 5 squared, that's just 5, right? The square root of 25 is 5. Square root of 9 is 3. Square root of 16 is 4. The square root of k squared would be k. So this turns into 8k times the square root of k. Because that k right here got left behind. That k got left behind. Again, the remainders, you leave them in there. The remainders, you leave them in there. And so the answer here is D. The answer is D. Hey, Oscar, it's all good. This is why we're here. We're going to work through the mistakes. We're absolutely going to work through these mistakes. So from there, so get the other k is out. Right, yeah, so you're not going to get that other k out. That k is trapped in there, can't come out because it's not a perfect square. So there, D will be the answer here. Now let's get into number 2 here, my party people. I got you. Hey, just because we got one wrong doesn't mean that's all wrong. You're good. You're good. So, hey, I got you, Oscar. So up next here, we're looking at x squared times 2x to the power of -2. All right, so everybody, what number is in front of the x if we don't see one number? What number is in front of it? Right, just 1. Just a 1. So everybody, what's 1 times 2? What's that going to be? Right, 1 times 2 is just going to be 2. Now, here's where a lot of us may be getting the heebie-jeebies. Did anybody here look at this and say, oh my God, there's a negative on the exponent? This is like me looking at decimals for the first time. Nah. Did anybody here look at it like that? Oh, since I'm tiny down here. Nah. But yeah, no. So in this case, again, we're just going to follow the basic strategy, everybody. We need to follow the basic strategy. I love messing with y'all, man. I'll tell y'all, teaching is the funnest thing I've ever done in my life. Let me bring myself back so you can take me seriously. So checking this out. We have x to the power of 4 times x to the power of -2. Basic strategy. What do we do when we are multiplying variables? Basic strategy. Yeah, we will add those exponents. Let's take care of business. So what this is going to turn into, let me use a highlighter here to show you what I'm working on. This turns into x to the power of 4 plus -2, which is the same thing as 4 minus 2. So when you add those exponents, we get what? 4 minus 2, which is what? 2. We just get 2. So that would end up being 2 to the power, or 2x to the power of 2, which makes the answer here A. I got y'all. So basically, I'm reviewing this as if these were video solutions for the math bootcamp. So I'm going to start doing that also in May, my party people. The new questions that I started introducing to classes, I'm going to start filming them live with you guys in class, and then have Coach Sheena and Isabella help me import them into the math bootcamp so you can revisit the problem without having to sort through all of the live lessons. So let's go in here and go to number 3. Again, guys, I got a list of ideas. If I could show you my office right now, I have 1, 2, 3, 4, 5, and then a whole 2 other whiteboards over there just littered with ideas that I've been wanting to try. We just don't have the manpower for it. But thankfully, I'm getting 2 more interns in a couple of weeks. So we're going to have way more power to do a lot more. So let's go ahead. Let's get to business here. We have a 2b cubed, all of that to the power of 4. So what we're doing here is we're going to go ahead now and apply the rule. The rule is we're taking a power to a power. So when we're doing a power to a power, what do we do with that exponents? What do we do with the exponents? Right, we just multiply. Only question my party people is, I don't see an exponent on that 2. What do I, what am I seeing? What am I seeing there? Yeah, that's just a 1. That's just a 2 to the power of 1 times b to the power of 3. So what we're going to have here is we're going to distribute, basically multiply that 4 with the 1 and the 3. So what we end up getting here is 2 to the power of 1 times 4, which is 4, times b to the power of 3 times the 4. So in that case, we have 2 to the power of 4, and that'll just be what it is. But then everybody, what's b to the power of 3 times 4? What's 3 times 4 going to be? Yeah, 3 times 4 is going to be 12. 3 times 4 is going to be 12. And there we have that. So if I'm taking a look at all my answer choices here, which one's the only one that could be the answer? Before we even do the 2 to the power 4. Yeah, that's the only one. That's the only one that could be it. Now, I'm going to show you how to do it. Let me just show you how to do 2 to the power 4 here. That's going to be the same thing as saying 2 times 2 times 2 times 2. So that right here is 4. That right there is 4. 4 times 4 is 16. So that's how we get 16b to the power of 12. That's how we get it. Right there. So there's D. I'm going to look at number 4 here. So what we're doing here is, well, I'm taking a look at this, and I'm going to tell you guys right now, I have a negative power. I could make that a positive if I wanted to. And that's exactly what I'll do. So I have the x to the power of negative 4 right there. And so what I'm going to do is I'm going to turn that into a positive power by flipping it to the other side. So everybody, when you flip it, when you put it from the numerator to denominator or vice versa, if it was the x to the power of negative 4 before, it's x to the power of what now? Yeah, x to the power of positive 4. So that'll be right there. That's where it goes. And so now it looks like we have x to the power of 4 times x to the power of 4. What is that going to turn into, my party people? What is that going to turn into? Not 16. What do we do when we multiply variables? What do we do with their exponents? Again, you always want to have this dialogue. You want to have this conversation with yourself. You need to have this conversation with yourself to understand what you're doing when you see what. Yeah, we will be adding those exponents. So this will turn into 1 over 2x to the power of 8. And that's what we'll get for answer choice C. Booyah. And there's number 4. Let me zoom out just a little bit here and get into number 5. So number 5. Number 5 over here, we have 3x to the power of negative 2. And really all we have to do here is just go ahead and modify the negative to make it a positive exponent. That's all we got to do here. That's all we got to do. So what we'll do here is this. We'll go ahead and just say, hey, this is the same thing as saying 3x to the power of negative 2 over 1. So what I'll do is I'll go ahead and leave the 3 where it is. Leave the 3 where it is. It's up top. But that x to the power of negative 2, I'll move it to the denominator to make it a positive 2. And so what we'll have is this goes to the bottom as x to the power of 2. That's all it is. That's all it is. And so now that we have that, we take a look, and the answer here is B. Boom. So the answers were for the first set of questions, D, A, D, C, B. Who's feeling pretty good? Who's feeling pretty good about that? Perfect. Perfect, perfect, perfect. So in a couple of weeks, once we get our new set of interns, we will have them working on the boot camp again. We are going to pause for a bit because our first 2 interns, they just finished the semester. And so they're not helping us upload everything into the boot camp right now. But we are going to we're getting 2 new interns starting not next week, but the week after next. So the week before my vacation, I'll be able to meet the new interns, get them up to speed, and then I'll have Coach Sheena and Isabella lead the way for the projects. But you can expect that to resume, and again, in a couple of weeks. So, hey, I'm expanding. What you mean, man? World domination. So with that said, I'm going to go ahead and give you guys the answers to the next couple of questions here. But again, like I said, we are going to have more and more questions just like this, about 900 extra questions to help you practice this. I got y'all. So number 1 here, this would end up being 10, because again, you can pull the 100 out to make it a 10, but then you have the 2 remaining. So the answer to the first one here is B. So excuse me and forgive me. I'm not going to show the work. I am going to give you the answers. So if you want to take screenshots and try to work it out on your own with your notes, hey, it's your thing. Number 2, 2p squared times 3p squared is going to be 6p to the power of 4. Next up, number 3, we have 4x squared to the power, all to the power of 3. That would end up giving us 64x to the power of 6. Number 4, we have 2x cubed divided by 2x squared. That will result in just x. And then we have 6x to the power of -7. That would be right here, b, 6 over x to the power of 7. So feel free to take these screenshots. I'm going to go and move myself over here. Take your screenshots. Make sure to send it to your mother. There you go. So there we have it, my party people. The last one is wrong. Oh, yeah, the last one. I was like, oh, I'm pretty sure, Lucas. I'm pretty sure I did my mathematics correctly. But yeah, so with that said, my party people, I'm happy that you guys really joined me today. You know, on a scale of 1 to 10, how enjoyable was this for you? With a 1 being, why did I even come? To a 10, be honest, you know, with a 10 being, you know, this really felt like I grew, I understood something a little better, and I know what I can apply moving forward. Good. I'm glad, guys. I really am. At the end of the day, man, you know, really what matters is that you're confident that you know that this is going to work for you. So it is 8 o'clock, and, you know, we are going to wrap things up at this time. But I do want to appreciate you guys and all the effort that you've always been giving and really just showing up to work and get better at this. I know it's not easy. And so, again, I do want to thank you guys for being here.